Okay, so we saw a little bit on intrinsic, extrinsic. I'll scroll down here. You can also identify if these properties of matter are physical and or chemical properties. And a lot of times they're going to be physical properties because they're properties about the physical appearance of that particular matter, right? So this is just a diagram that kind of connects the chemical versus physical properties that we talked about already, and how intensive and extrinsic properties are actually under the category of physical. And so things like this depend on the amount, so they're extrinsic. Things like this it doesn't matter. It's just a characteristic of that particular matter. So these are the different ones that are under the intensive category. So it relates back to what we've already talked about. Okay? So if I need, this is just a visual for you. I will go back as needed, but you guys already read about this a little bit. I'll give you another couple of seconds there, but you don't have to click on every word. Okay, so what is the law of conservation of matter? Raise your hand. Like, you can say in one sentence. Go for it.
Whatever goes into the reaction that comes out.
Okay. What do you mean whatever goes in? Like, what specifically are you talking about?
Elements and the number of atoms.
Right, the number of atoms of a particular, like, carbon or hydrogen or whatever that goes in will come out, right? So the matter itself will be conserved. What else is conserved though with it? You know, the mass of it, right? Because every atom has a different mass. So I don't know if you guys can see some of the numbers if you have your table out. What is the mass of hydrogen? Can you see the atomic mass on there? 1.008. What's the atomic mass of oxygen? Okay, so we have these different masses that are associated with the periodic table of elements. So mass that goes in is the mass that comes out. So we conserve it because we can neither create nor destroy matter. Okay, we'll come back to this part. All right, so what goes in, what comes out? The word that you did not use that I really like to use is just that it is rearranged. So like we had earlier in number 5, you guys said hydrogen and oxygen go in. What comes out? What comes out? Water, H2O, okay. And there happen to be 2 of those and 2 of those. So what goes in just gets rearranged. The atoms bond in different ways. And we do not create or destroy these products and reactants. We just rearrange them. So that's a good word for that. So write down what you need to. We're going to do a couple of examples, and then we're going to hit our lab. Okay? Easy stuff today. And so I will note that when I say matter, the law of conservation of matter, I'm referring to number of atoms. But when I say it the other way, I'm talking about the law of conservation of mass. I'm talking about the mass of those same atoms. It's just a characteristic of the atoms. So you can say it either way. It means the same thing. Matter has mass. I got it. Okay, so looking at this first reaction, you guys know a little bit about chemical reactions, I'm thinking, but I'm trying to gauge where you are, so you gotta let me know. Do you know what kind of reaction this is when you take 2 separate things and you put them together?
Fusion.
Fusion has another word, it's called synthesis. To make, right, that's I figured that's what you meant. Okay, so when I take one thing like this and I break it apart, breaking things apart, breaking down, so there's the D. Decomposition, good, this is decomposing or decomposition. We're going to study these a lot more. Then we even have some where you can see that C replaces what in this first compound? B. It's called, and so since C is just a single guy, C replacing B is called single replacement. Yeah? Told you, we don't get creative. It's like very logical in what we say. So what do you think this one is when you see that 2 of them switch? Double replacement, right. So synthesis, decomposition, single replacement, double replacement. So that's just some food for thought right now. But we are going to get into that in a lot more detail. These are just different types of reactions. Okay, this reaction we all know, right? Okay, let's just make sure we know how to balance this and identify that all of the atoms are conserved, right? So when you're looking up here and you have a coefficient, the coefficient is distributed to everything in the compound, okay? So this carbon dioxide, 6 of them means total, how many carbons are present? 6, right? The 6 times, what is this imaginary number after the carbon? 1, right? Same thing here, 1. Same thing, well, no, that's it, okay. So 6 times 1 is 6 carbons, okay? How many actually, let's go to hydrogens. How many hydrogens in the first part? 12, 6 times 2 actually, right? So there's 12 hydrogens. How many oxygens total? Keep going. 18, because you see 6 times 2, so that's to how many? 12 plus the 6 times 1, so that's 18, right? So 18 oxygens. Okay, those should all appear in the products because we are not creating or destroying, right? We're just rearranging. So how many carbons are present? 6, and I've already balanced this chemical equation for you, so that's why I got the coefficients out here. There's a 1 coefficient here, so you do 1 times 6, which is 6 carbons. Okay, how many hydrogens? 12, because there's a 12 right here. 12 hydrogens, and guess what? How many oxygens? 18, yes, because there's a 1 coefficient times the 6, so 1 times 6 is 6, plus 6 times 2, so 12 plus 6 is 18. So you can confirm that, and that's basically just balancing a chemical equation, because we always have to balance. The reason we balance is because we need to follow the law of conservation of matter, or mass. That's just what we have to do. We have to abide by our laws, just like you drive the speed limit, right? Well, who can drive? Woo! Okay, some of us can't still. It's not that cool. I mean, I don't like driving that much, so you're not missing out too much. Okay, so we have to balance because we have to follow the law of conservation of matter. Let's try to balance a couple of our examples from yesterday in our lab. After we go through, we just did this. Okay, notice, tell me, I think we talked about this already. We talked about combustion being a chemical reaction. We talked about tarnishing of silver yesterday in warm-up, yeah? We talked about rusting. Rusting refers to mainly iron. You will notice that all these have coefficients already. So 1 carbon, 1 carbon. How many oxygens? 4. How many oxygens?
4.
How do you see 4 here? So there's a 1 times that. Right, there's 2 oxygens here, and a 2 times 1. Right, you're right. I'm just making sure. You see 2 plus 2 is 4. Okay. We can do that. We've seen all these types of chemical reactions probably before. We're going to see them a lot more, but we are always following the law of conservation of matter. All right, so this one, tell me, let's look at each individual atom or element and balance it. And you don't have to write these down. You can. I just want to give you a couple more examples. So how many sodiums are in this one? 1. How many sodiums on the product side? 1. Okay, sodium's good. Sodium's good. How many chlorines are in this one? 1. 1. Okay, so far so good. No need to add any coefficients. You'll notice I don't have any coefficients here. So I'm showing you how to balance. I just check 1 by 1. All right, next. Silvers? 1. Silver? We're doing good. Nitrogen? Nitrogen? Hold on. Nitrogen what? 1. There's actually an imaginary 1 after these nitrogens. Good. And oxygens? 3. So do I have to add anything? That's balanced. What are the coefficients on all of these? 1s, right? So that's a coefficient, 1, 1, 1, 1. Okay, 2. What do you notice is not balanced? The number of hydrogens, right? So I see 1 on this side, 2 on this side. I need to add what to that side? A 2 coefficient, right? All right, so when I add that 2 coefficient, what else have I just changed? Chlorines. How many chlorines are here now? 2. How many chlorines are here? Yay! Okay, so I don't fix anything. I already kind of fixed it. How many magnesiums are here? 1 and 1. Okay, so the coefficient ratio is 2 to 1 to 1 to 1. Yeah? Kind of getting it? Okay, and then the last one. This one's easy, but it's kind of weird because it looks different. So, just BT dubs. This was our precipitate that formed. Okay, that was the silver chloride precipitate that formed, that little white stuff that formed in reaction 3 yesterday. And you were like, what is this? Okay, we had 2 liquids that formed a precipitate, chemical change. And then this one, we added hydrochloric acid to magnesium. This gas was made, and with it came bubbles. And what else? Heat. It had gas that came off, and it was heat. It was heat evolution. So we saw those two reactions yesterday. And then this one, we had this colorful substance, copper 2 sulfate pentahydrate. What color was it? Blue. And then what happened? It turned white. And then on the test tube, you saw what? Water vapor, right? So you saw that condensation of water vapor on there. So what did you do in the reaction? You heated up blue stuff, and you actually chemically altered it. You split this in half. You decomposed it. Because note, this right here looks similar to copper 2 sulfate pentahydrate, but this is just straight up copper 2 sulfate. None of the water stuff. Water is separate here, so it was a chemical change. That color change that happened was a chemical change. So what we did here was I just took out the waters, so I need a coefficient here to prove that I have how many waters still? 5. You have 5 times more water than copper 2 sulfate pentahydrate. I mean, copper 2 sulfate. So that's just a quick review for history. So you can do balancing, reactions. We're going to hit that more in Unit 3. Okay, you need a piece of paper? We're going to do our lab. Told you this was fast. So you guys get to collaborate some more. Let me give you a quick rundown of what we're doing. There are, you probably have noticed in the lab notebook, there's some repeat labs. That's because when I teach other classes, other levels of chemistry, sometimes I use different labs, so you have to pay attention to what lab you're using. The one that you're using is literally called the Law of Conservation of Mass lab, and it's got like a balloon with some pictures like that on it, but yours is true to a page. You'll see this on the front of the page. So it looks like this, but it's got a little soda bottle, okay? So basically what you're doing is you have 3 trials of proving the law of conservation of matter, or the law of conservation of mass. So some of these trials will work out well, and they will support your law. Some of them will not. So you're going to have to look for percent error, or also called percent difference. So when it says percent difference, you can just think of it as percent error. It's the same thing, because it's the difference in what you got and what you should have gotten. So at the end of the lab, you will need to clean out, if you have the 2-liter bottles around, clean out the soda bottle for me. All the chemicals will be neutralized together, okay, because we have an acid-base reaction here. Acids and bases come together to make neutral, so everything's fine to go down the drain. You can read this part when you get to the percent difference. And I think that everything is pretty much self-explanatory. I do have a limited number of scales, so you have to share your scales. Do you match directly on the scale? No. Right. You have a weigh boat and you have weigh paper. On one of the parts of the lab, you're going to have to take the weigh paper is just like wax paper. You're going to put your stuff on it, and then you're going to roll up the wax paper to keep the chemicals separate and drop it in the soda bottle. And you have to close it up really fast. If not, the reaction starts and you lose mass. Okay? So, last thing, after you finish, if you have not finished the classification of matter cards, because my 4th period didn't get to finish this, so this is mainly for them because we have like less time in that class, 20 minutes less. So you guys need to finish your classification of matter cards if you did not last week. Start pumps at 1, and then if we get to multiple choice quiz today, we will. If not, I'll save it for another day. Okay? So do not stress, but I do want you to start your homework. Okay? Same groups. Let's go. Here. I'm still grading. Yeah, I'll let you know. Okay, listen. You will be putting vinegar and baking soda in a beaker. It says 600 milliliters. You do not have a 600 milliliter beaker. I would prefer you to use at least a 250 or 400. A 100 will boil over. Okay? So you're going to find the biggest beaker you have, and the scale will match. If the scale says error, that means you have something that's too heavy. If you need other beakers, though,